Okay, so my screen is visible, right? Okay. So this is the first problem, and in this problem we're given that they basically are two players playing tennis match, Sonu and Titu, and the person who has won more sets win the match. But they are smart, and if they notice that at any point one of them has no chance of winning the game, they will stop the game right then. So we are given X and Y. X is the number of sets won by Sonu and Y is number of sets won by T2. So we have to find what is N. So this is a very simple problem. What we can do, see, if the game has already stopped after X and Y, so one of them have already won, right? So whatever is maximum of X and Y, whatever is maximum of X and Y, N will be equals to twice of it minus 1. Why twice of it minus 1? Because if let's say if this was exactly twice of this, then there is still a chance because all these sets have been won by maybe if X is more. So maybe these sets have been won by Sony. So maybe Y is this much. So these sets are still remaining. So Y is this much. So there is still a chance that maybe Y can be equals to X, right? So that's why if they are stopping, they know that there is no way of winning. Like beyond this player cannot win. So that's why our answer is simply 2 to the power 2 into 2 times x minus 1. 2 times maximum x or y minus 1. Is it clear? Okay. So let me show you the implementation. So this is the implementation. So first taking x and y as input, then printing 2 times maximum of xy minus 1. Now going to the next problem. So in this problem, we are given that we have n integers and we are allowed to remove at most one element. Like this means that it's not always that we have to remove it, but we can remove at most one element and we have to find the minimum final XOR of all the elements that we can achieve. So first of all, this is like if there are n elements, first find the XOR of all of these elements. Then we can use the property that if we have, let's say 2 times x, the XOR of same elements is 0. So this is nothing but, let's say this is A1, A2, A3, A4 up till AN. Then what I can do if XOR is XOR of all of these, this is my XOR result, like XOR of complete array, all the elements. So what I can do if I have XOR, like I'll take XOR of this thing and A1. What is this? This is nothing but XOR of all these elements, right? If I take XOR of this and 2, A2. So this is nothing but XOR of all of these elements. So first of all, my answer will be nothing but answer is maximum of XOR. That is the XOR of complete all the array elements. This way, XOR of this with each and every element up till XOR with AN. Is it clear? Okay, so let me show you the implementation. So this is the implementation. First, I have taken A as input. Then initially I have calculated my answer like the XOR of all the elements. This is my temporary variable. It is first initialized to answer. Then I've gone through my each and array element and my answer is minimum of, okay, I think I have written maximum here, right? This shouldn't be maximum, it will be minimum. Like we have to find the minimum value. So answer is minimum of answer E XOR temp. So this is temp is the initial XOR of all the elements, and I'm taking E each time, each of the elements. Finally, I can print my answer. So is there any doubt in this?
No.
Okay, so let's go to the next problem. So the next problem is this. In this, we are given that we have an array A. Let's suppose there's an array A of size n, where n is even. The alter ego of this array A is another array B, which is computed as follows. We start with empty array B, and for each I from 1 to n by 2, that is half, we insert the elements sum of ai plus n by 2 and the absolute difference between these two at the end of array B. Then we can rearrange array B in any order. So what we have to do, we are given some array B and we have to check whether or not there exists an array A such that this is the array B that we get. And there is one more thing, that if there are more than one arrays A of such kind, we have to find an array A which is having the maximum sum. So let me explain the problem here. Let's suppose, see, this is, we are given that the size of array is even, right? So let's take this as 8. So how is array B created? First, this is A1, this is, so we'll insert this and this in array B. Then we'll do the same thing for these two. So it is A2 plus A6 and A2 minus A6. So similarly for these two, and then for these two. Now, what we have to do, we're given an array B and we have to first find whether array A is possible or not. So tell me one thing, see, let's say this is array B. It will also have n as size and n is even. So that's why 8. So first of all, if let's say I'm having this as the odd value, what does this mean? If this is odd, it can be either sum or difference, right? There are only two things, absolute difference. So if this, like this value is either, it's going to be like the sum of two elements or the absolute difference between two elements. So anyway, let's take this as sum. So it means there are two elements x and y. The sum of these two is odd. And now if the sum of two elements is odd, what does this tell us? One of these is even and the another one is odd. Then only the sum will be odd. Otherwise, it is not possible for sum to be odd if both are even or both are odd, right? So by the ways, if we take the absolute difference between these two, this will also be odd only. Are you getting my point?
Yes.
So the point is, if we are getting odd, like if the sum is odd, it doesn't matter if this is odd corresponding to some xy, whether it is sum or absolute difference, there will also be one more odd. Like if this is sum, then this will be the absolute difference. If this is absolute difference, this will be sum. But these odd values will always appear in pair. So the thing is, we should get like the number, let's say this is count odd, the number of odd values in array B, it should be divisible by 2. It should be even number. Right? If it is not an even number, then the answer does not exist. Our answer is simply -1. Is it making sense?
Yes, it's making sense.
Otherwise, the answer always exists. Why? First of all, like let's forget about with that. We have to maximize the sum of array A elements. My point is the answer always exists. Why? Let's say I have taken only the values from array A that are even. Like we can do the same thing for odd also. Okay, from this point. Odd. 1, 2, 3, 4, 5, 6, 7. There will be these will be also occurring even times because the odd values are occurring even times and n is also even. So let's say I have sorted these values in increasing order or non-decreasing order, whatever. Like we have sorted these values. So these values are sorted. Now this is the first value and this is the second value. So can I not say that there are two elements x plus y? Their sum is 2 this is the bigger value because, and let's say my x is going to be the bigger element out of x and y. Like x is more than equals to, I'm assuming x is more than equals to y. It doesn't matter, but I can write this equation also. Like I'm not going to write this. Why? Because I'm assuming x is more than y. And this is equals to 1. Like the number 2 and the number 1. So this is simultaneous equation, right? We can always solve these two equations and get values for x and y. It's always possible to solve these equations. Why? First of all, like I have always already told that it is not possible, like all these values in this array are even. So the sum of these two will also be even. You will get 2x as even, x will be something, some number, and you can substitute that x in any of these equations and you'll get y also. So both of these numbers are integers and they are unique. Like it's not like you cannot find these values. Same thing is applicable for this also. If you take any two odd values, let's suppose this is sorted in this order. So this is the second value, this is the first value. Sum of two odd values will be even. 2x is even. You can find the x value from there and you'll get the y value after substituting back into one of these equations. Is it making sense?
Yes.
So one thing is clear, answer is always possible. We can always, like we can sort these values and we can find xy for these two, xy for these two. Like these values occur in pair, right? So after sorting this, we can find xy from here, xy from here, xy from here. Those are nothing but, if let's say this is my array A, the first one will be x, and there are 4, right? So let's say my array size is 8. So this will be x for first time, and this will be y for second time, like for the first time. Then x here, y here. So this way I can find these values. But the thing is, I don't have to just find any values. I have to maximize this, right? This is the second condition, that if there are many array A's possible, we have to maximize this. So let's look at these. What is array A? Array A is nothing but, we are getting array A as, like what is x? X is nothing but like we can write it as this 2 plus 1 divided by 2, right? Yes, no?
Yes, yes.
And we can write y as x minus,
1.
like what will it be?
X minus 1.
Y will come this side and 1 will come this side, yes. Now, eventually, we'll find the sum for every, like this way we'll find x and y for all the values, right?
Yep.
So, okay, like let me write it again. I think it will be, see, what we have, let's say we have even integers 1 2 3 4 5 6 7 8. These are these 8 integers. Now I am saying that I can always like choose, if I sort these, I can choose these two elements in like all, every two elements in pairs, and I can find some x and y, and I can put those elements in my array. But what I have to do, I have to maximize, this is my array. I have to maximize some of the values that are in this. So if we, let's say, if we like, if we are pairing, let's say this is some array element, some element here and some element here. So what is the values that we are getting? We are getting like here we are getting, let's say this is a1 and this is a1 plus n by 2, right? So I had two equations, a1 plus n by 2 is equals to 1, and a1 minus, I'm assuming that a1 is more. right? This was it.
Yes.
This was the equations, right? So now a1 is nothing but in terms of 1 and 2, it is 1 plus 2 divided by 2, and a1 plus n by 2 is, if I write completely in terms of 1
A1
and 2.
minus 2.
Yes, you can write it like that also. Okay, let me write it like that only first. One, like you are saying this, a1 minus 1 plus a1 minus 2. You are saying this thing, right?
Yeah.
So this is okay. This was also written here. But can I not write a1 as this thing? Let's substitute a1 as a1 is this thing, right?
Yeah, I got it.
So
1 plus 2 by 2 minus 2.
so what is this? This thing, right? No, no, no.
Yep.
None, there's a minus. There's a minus here, right? So now if you see, if I take sum of what will be my final, like let's forget about these elements for a moment. These are kind of my x and y. Finally, the array A will be nothing but the sum of these values only, right? So if I find sum of this and this, it is nothing but it is only first element, right? The element which was more. I assume that this element is my more and this is less, right? Basically, this is like here also I can, like I assumed, like okay, here I have done it reverse. Like I assume 2 is more than 1. I have sorted my array this how, right? So say 2 was more than 1. But in this, I have taken this as my more bigger element 1. So what does this tell us? That if let's say these two elements are there, if I take these two elements, the element which is bigger will appear in my array is sum, and the second element will be ignored, right? The smaller element.
Yep.
So what we can always do, these are, let's say, n values. We know exactly half of them will come in our sum and half will be ignored. So let's pick the maximum n by 2 values, biggest n by 2 values, right? Because
Okay.
those will appear in our sum and the rest n by 2 which are smaller will be ignored. So now the problem is very simple. Make two arrays. First one is in which all the even values occur, and the second one is in which all the odd values occur. Why? Because I have just told that if there is a odd sum, then this can only be paired with an
Modulo 2. Yeah.
odd difference. Like it's not possible that your sum is odd and you're having differences even. So that's why. Then sort these values in this, maybe this and this, and pick these values. Okay, this is having even size. So sort these, and then maybe if you sort these, pick these values as your, like try to map these values. Like let's say this is your one and this is your, you can choose any of the twos, you'll always get valid equation. So let's say you pick these two or you pick this as your two, so then your equations will become your x plus y is 1 because this is more, and x minus y is 2. From this you can find x and y simply. First let's say 2x is 1 plus 2. From this, find x as 1 plus 2 divided by 2. Substitute back in any of these equations, get the value of y. In your answer array, make sure that you get your like x and y is in correct order. So if x is coming here, y will come at position, this position plus n by 2. So this is your y. Similarly, keep doing this. Like pick any value from here. This will come in your array A when you're adding, like when you're finding the sum, and this value will get ignored. So this way we can do this. Similarly, we'll do this. We'll pick these two and we'll pair them with these values. Finally, we'll make our array A. Is it clear?
Yes, it's clear.
Like the proof is clear, right? Why we are doing it like this?
Yes.
To get the maximum sum. So let me show you the implementation. So first, I have taken n as input, then I have taken array A as input. Then this B is all the elements that are odd in array A. Like instead of naming it as A, we should have named it as B. Like array B is given to us in input. Like what I have done it, like I have named it A only. And B is all the elements that are odd in array A, like in input array, and C is having all the elements that are even in input A, in input array. So if the size of these is odd, any of these, like if one is odd, another will be odd only because n is even. So if the array B, which is odd number of elements in array A or input array, are given to us odd number of times, then the answer is simply -1. Otherwise, what we can do, we can sort these arrays. I have sorted them in non-decreasing order. You can sort them in, like I have sorted in non-increasing order, which is decreasing order. You can sort
Yes,
them
yes.
in another manner also. Then, like I have explained, I'm going through the first half and I'm pairing them with the second half. So this is it. So this is how, like, first find the sum. X is sum of these two divided by 2. This is my position. At this position, it is X. Position is nothing but another variable. So then at position plus n by 2, the value is this, Bi. Like I have just substituted this in another, like X
I
in
got
one
it.
of the equations. And the same thing is done with C also. The elements in array C, which are even elements. Finally, I can print my answer vector. Is it clear?
Yeah, it's clear.
Okay, so let's go to the next problem. So in next problem, we are given that we have two arrays A and B, and each of these is having a color. Now, what we can do in one operation, we can swap any two elements in array A and array B if they have the same color, and our goal is to do like any number of operations and eventually have elements in array A be in non-decreasing order, this order. If it is possible, we should print yes, otherwise no. So see, we are given two arrays, and let's say this is the color. So first of all, see, if the color is 1, we can have any values here. See, if you have to make n values, what you will try to do greedily, what should come to your mind, the first value should be, if eventually you want this order to be followed, you have, let's say, 50 options for this place. What will you try to do? You will try to pick the smallest value here, right?
Yes.
Why greedily? Because the smaller value you pick up for this place, the more number of options will be left for this place. See, if there are 5 options, if you choose, let's say, 100 here, if you choose instead of 100 as 1, this 5 cannot decrease. Like this is like this is simple reasoning, right? This cannot get worse. If you have 5 options, it will increase only. If your value here get decreased. So that's why if you have 50 options here, you'll try to pick up the smallest one. Here, if you have, let's say, 10 values which are more than the smallest value here, which is, let's say, 1. So if there are 10 options here, again you'll try to pick from those options the smallest value. So this is exactly what we'll try to do. So for the first place, any value that is here, 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 or here can be placed here. Why? Because let's say this is the smallest value. First, I'll bring it here, then I'll swap these two. So at this place, whatever value color 1 in both of the arrays, color 1 is having, the smallest value will come here. Now, this is different. 4. 4, maybe it's appearing here and it's appearing here also. But the thing is, if it is not appearing in array B, even like at least once, I cannot swap these values. It should appear in array B. So I cannot have any other value than this value itself. So I just have to check with this value that this value shouldn't be more than previous value. If it is not, it's fine. If it is, I'll simply break my loop here only and say that the answer, it's not possible. Otherwise, now this is my previous value. Here, the value is again 1. So now one of the smallest values of color A, 1, has already been used. I'll pick this next smallest value and try to fix it here. Then comes the 3. Again, pick the smallest value for 3, whichever is there. try to fix it here, and at each position we'll try to see that the smallest, like if there is no possible value, let's say this was the previous value and this is color 1. So if there is no value in color 1 left that is more than this previous value, more than or equals to, then answer is no. Otherwise, if there are some values, we'll try to pick the smallest of such values. If we are able to do this for all the n places, the answer is yes, otherwise it's no. Is it clear?
It's clear.
Like, is there any doubt in this?
No, I understood the question properly.
Okay. So I'll show you implementation. So this is the n that is given to us in the input. Then this is array A, color for array A, array B, color for array B. So I've taken all these in input. Then I'm using a multiset. You can, like, it's not necessary that you solve this using multiset only. This is map. Again, no need for this, but I have taken map for just checking whether some color is appearing at least once in array B or not. So I've inserted all the values according to their colors in these multisets. These are basically for each color there is a multiset, and similarly done here. And this is just marking for all the colors that appear in array B, marking all those colors as 1. So this is my final answer. Like if this is my flag, if this is 1, answer is possible, otherwise it's no. X is like this will be my previous. So initially I'm taking it as -1 because it doesn't appear in both of our arrays. Now from 1 to n, I'll first check if this color, like the color for which, like the color of whatever the color of ith array, like element in array A is having, if that color doesn't appear in array B even once, I cannot swap this element with any other element. So if in case my previous element, that is X, is more than the current value, because I cannot swap this with any other value, my F will be 0. Otherwise, I'll update my previous and I'll continue. Otherwise, if this is not the case, I'll first check, like you don't actually have to check this. This is not possible. Like if X is more than, this is the previous value is more than the biggest value that you can have at this position. That is the biggest value that is available to you in both arrays for this color right now, currently. If the previous value is still more than that, the answer is not possible. Otherwise, just take the smallest of such values, I have found it using lower bound, and remove that value from your multiset corresponding to this color. Finally, if the flag is 1, answer is yes, otherwise the answer is no. Is it clear?
Yes, it's clear.
Okay, so that's it, and thanks for joining. Bye-bye.